Students, in this class we would be learning about inheritance in Python. Now there are many different types of inheritance available in Python. So foremost we will start off with what is called as single level inheritance. So I'm going to give you an illustration for this, and probably after we have completed this illustration we will move on to other forms of inheritances. So foremost, let me design a class. I'm going to say class, and then I will give a name as addition. Now in this case I'm going to define a method. Now in this particular method we would have to receive the first number from the user. So it's going to be input, please enter the number. And since it is a string that we are getting, we will have to convert it into integer and make it ready. So what I'm going to do, I'm going to copy this line of code and I'm going to change this to second number. So we got a method in this class asking for inputs. Now I will also declare another variable called as adding. So in this case it's going to be self dot first number added with self dot second number, and after that I would want to print this number. Print the addition is equal to, I will concatenate. Of course we need to convert the quantity from integer to string for concatenation, so I'm going to say self dot adding. So this is a method that is featuring in the class. Now if I were to create an object, say addition, for this class, then clearly when I execute this, the input will be requested and the addition will be performed. Okay, so another important thing is that we need to call this method. So I'm going to use the object in calling the method. So this is the method and we can now run the program. So I'm running it. Enter the first number, say 121, enter the second number, say 200, and the addition is 321. So that's fine. Now what if I want to have another method and another class? So this is a class which performs addition. I want to have another class which is going to perform multiplication. So let me place in that class. And I'm going to add in a method multiplying two numbers, and in this method it is going to also require two inputs. So I'm just going to copy this entire thing and I'm going to paste it here. So now just to have some identification, I will copy this and then I will paste it here, second number to be multiplied. So we have two numbers here, and then instead of plus we need to perform multiplication. What we are going to do is, I'm not going to create an object for the first class, and I would be creating the object for the second class. Now the concept of single inheritance works in this fashion. Now clearly all of the methods that we see here for the first class would be inherited by the second class if I am able to place within the parentheses the first class. So the meaning is, this particular class which you see here, multiplication, is actually the child of the class addition. In other words, addition is the parent of the class multiplication. So the advantage of being a child to addition is that this particular child will inherit all of these methods that are present in the addition class, while the addition class itself will not have anything to do with the methods present in the class multiplication. So being a child, you not only get to keep the methods that you have, but also you can use the methods that are available in the parent class. So how are we going to use it? So I'm going to create an object called computation for the second class. So it's going to be multiplication, and an object is created. Now using this object computation, what I'm going to do, I'm going to access the methods that are present in the first class, which is a parent class. I'm going to give that method here, and I'm also going to access the methods present in the child class. So that is also achieved here. Now if I were to run it, I would have to provide inputs for the first method, which would add and give me the result, and I would have to also give the input for the second method, which would multiply and give the result. So just to make things a little bit more representable, I will just give a print statement. So I will say print enter numbers to perform addition. Okay, so that is going to be the print statement for the first method, which is the parent class, belonging to the parent class. And I will also give a similar print statement, enter numbers to perform multiplication. So now we are all set to go. The output is going to be, in this case, print the numbers multiplied. Is equal to concatenation str. You have to convert the output to string. So this is going to be multiplication, so I just want to change it to product, and I'll place this variable there, self.product. So this would complete the output for us. So the numbers multiplied is equal to str of self.product. So I'm running the program. You can see the output. Enter numbers to perform addition. I'm entering 12000. Enter the second number, say 2000, and the addition is this. That's fine. Now enter the numbers to be multiplied. Let me enter 20212. First number, second number 12, and the number multiplied. This is the solution. So clearly you can see that I have used inheritance in achieving my target objective, that is to perform addition as well as to perform multiplication. And how did I achieve it? I achieved it through the means of, which is called a single level inheritance. So in this case, you got the child inheriting things from the parent. Now the next example would be multi-level inheritance. So I'm going to demonstrate multi-level inheritance in this case. So clearly what we see here is this particular class inheriting things from the class addition. I will design one more class. I will say class division. So in this case, this division class is actually the child of the class multiplication. So what we see here is division being the child of multiplication and multiplication being the child of addition. So you got what is called as multi-level inheritance. So let me formulate this illustration. So in this case, I'm declaring a class called division, and I'm going to have a method. I don't need these things, so I'm removing it up. So in this case, what I'm going to do is I'm just going to state here the class name, which is multiplication. So I'm just going to place that within the parenthesis, multiplication. So that means this would inherit everything that belongs to the class multiplication, and multiplication will inherit everything that belongs to the class addition. So let me just copy this particular method. I'm just going to copy this method here, and I will just change the name to dividing two numbers, dividing two numbers. So print enter the numbers to perform division. I'll just change it, enter the number to be divided. So that would be the number that we are taking in. That's a better way to say. So we got the first number and the second number, and in this case it's going to be division. So division is equal to first number divided by the second number, and I want to take only the integer quantity. So that would be int of these two quantities. So in this case we can achieve all of these addition, multiplication and division using the following technique. So what I'm going to do is I'm going to create an object. I'm going to say division is equal to the class division. So an object is created. Object to call the method, to call this method. What I'm going to do, I'm going to also use the same division to call multiplication, and then I'm going to use the same division to call adding of two numbers. A beautiful example for multi-levels. So one more thing I need to do here is I will have to print the thing out. I would have to say print the division equals, so you will have to say plus str of self.division, and let us run it and check it out. So clearly it says enter the numbers to perform division, or I would say 12,000, and I want to divide it by 40. So this is the output. Now it says please enter the numbers to perform multiplication. So I will enter 12,000 and I will enter 40, and this is the number that we're getting when we multiply. Now it's time for addition, so I'm going to enter the same number and I'm going to give 40, and this is what we have got. So this is a beautiful illustration by which we have demonstrated what is called as multi-level inheritance. So this completes the multi-level inheritance, students. So we have seen in this illustration single level inheritance and multi-level inheritance. We will move on to the next illustration. Students, the next what we are going to study is what is called as the hierarchical inheritance. So let me write those things down. So we have already finished what is called as multi-level inheritance. This is already done. Now the next inheritance we are going to talk about is hierarchical inheritance. We got the addition class. Now the multiplication class is inheriting everything from the addition class. So multiplication class is the child of addition class. Now in this case division class is actually the child of multiplication class because I have placed multiplication within the parenthesis. Now instead of placing multiplication inside the parenthesis of the division class here, if I were to place addition inside the parenthesis, then the division class becomes the child of the addition class. So this is how the hierarchical inheritance works. In this case what we can do is the division class here can utilize only those methods that are present in the addition class. It cannot utilize anything that is present in the multiplication class. So because addition class is the parent for the multiplication class as well as for the division class. So multiplication class and the division class are actually siblings, right? So they can inherit everything from the parents, and that is exactly what we are going to see here. The best way to understand this is by illustration, as always. So an object being created for division, and using the division I am able to access the method over here. This is the method that I can access, but I would not be able to access the multiplying two numbers method which are present in the multiplication class. I would just run the program and show it to you. So I'm executing it. The moment it comes to calling the second method, clearly it says that the object has no attribute multiplying two numbers. So that is what I really meant. So this division cannot call the methods present in the multiplication class because these two are merely siblings. So they cannot share these methods. In other words, the division class cannot access the methods present in the multiplication class. As simple as that. But what I'm going to do is I'm going to remove this off. Now, when I remove this off and when I execute the program, clearly division would be able to, in other words, the object division which is present in the division class will be able to access those methods present in the addition class, because division is the child of addition in this case. So what we're going to do is we're going to run the program. I'm going to run it and I'm going to show to you that the program would run without any issues. So enter the number to be divided. I'm going to say 16 and the divisor say 2. Output is 8. Now clearly, as I mentioned to you, using this division class I can access methods present in the parent class addition. So in this case, enter the number, first number for adding. I'm entering 1 to 4 and then I'm entering 10 and I'm getting the result. So this is how we have to, or this is how we can use the hierarchical inheritance, students. So we have finished single level inheritance, multi-level inheritance and hierarchical inheritance. So we will move on to the next one, which is called as multiple level inheritance. Students, in this illustration I'm going to show you how multiple inheritance works. So now after hierarchical inheritance we got what is called as the multiple inheritance. Now, how does this inheritance work? Now, you got one particular child that would inherit every method present in two of the classes. What we're going to do is we're going to have two parents. So I would take addition as a parent and then multiplication as a parent. So I will remove this addition from the parenthesis. Now, addition and multiplication would be the parents for division. So within the parenthesis I will just place in addition comma multiplication. So that would mean we got a child which is inheriting all the attributes from the class addition and the class multiplication. So just to use the same illustration, what I'm going to do is I'm just going to modify this. I'm going to remove these two things. I'm going to say, I'm going to take this off. So in this case, this would be giving us the output. So I will just say output for addition. And then the variables are there, first number and second number. And these two variables would be passed from the division class here, because division is actually inheriting everything that belongs to addition and multiplication. So we don't need to exclusively keep variables in addition. So we would use the same variables. In other words, we would pass the data from the division class. So we are receiving these two numbers, the first number, second number, and the same first number, second number would be sent to the addition class there. So for that, the first step is I'm creating an object here. So the first thing is basically this is calling the method here, dividing two numbers, and the second one is adding two numbers. Now I would also want to call the method that is present in this particular multiplication class. So I'm going to say output for multiplication. I'm going to take the variables out. So I'm just going to say output for multiplication. I don't need to have these variables here. I would just use the same variables that I'm receiving through division class. So we are not creating any objects for multiplication. So in this case, the numbers multiplied would be received from the division class. So that is why I'm using the terminology multiple inheritance. So we are going to run the program. So we got two classes which are giving all their methods to the child division. So we have to do one more thing. I want to call the method multiplying two numbers. So that is the method I'm calling them. So the output would be numbers received using the division class, because this is the method that we are invoking first, and then the second method would be from the addition class, and the third one is from multiplication class. So all of these have been invoked using a single object created by the division class. So let me just run this and show to you how it looks. So enter the number to perform division. I'm entering, so 16 is the number I'm entering. So divisor, I'm entering 4. The division is 4 divides 16 4 times, that's fine. The output for addition 4 plus 16 is 20, that is also fine. The output for multiplication is 16 times 4 is 64. So this is beautiful. So just by using the concept of multiple inheritance, I was able to access the methods present in the class. Welcome students. In this class we would be learning about multiple inheritance from the context of the init function. So let me put that down. So this class we will be learning about multiple inheritance from the context of the init function. So now it is very important that we understand the concept of multiple inheritance from the context of the init function. Now it is imperative to know that whenever we are talking about inheritance, indirectly what we are talking is we are actually talking about code reusability. This is what is our primary objective. So having mentioned that, let us proceed on with the class. The objective for this program is to get students record, and the students record comprises of two elements. So I want to place the comment here. So student record comprises of two components. So component one is academics, right? Academics, and component two is extracurricular activities. So this one is going to be ECA. Now the output should comprise of academics with ECA. So that is going to be the output. So what I would start off is I would start off with the student's academic record. So let me start off with this class, I'm going to start off with the student academic performance. So this is going to be my class, and in this class I'm going to define the init method and start off with this. So let me declare a variable self.mathMark is equal to input of, please enter the math score. So the user is going to be giving us the score. I want to convert this first into integer, and then I'm going to say whatever score that I'm going to get, I'm going to convert it into 100. Okay, 100%, and then I will publish the score. So print of math score is equal to, so I will place a concatenation there and convert this to str of self.mathMark. So this is how it's going to be. Now let us create the object. Before we could create the object, I want to declare another class. So this is going to be student record. So that means we are publishing the student record here. So I'm going to define init class over here, and then I'm going to give a print statement, print asterisk times say 40, and then I'm going to say print student records, and then probably I will give another print over here. So now the idea is to get the information from the base class. Now this is going to be the base class student score, and this is going to be the child class. So in other words, this is my parent and this is my child. So for that, so we are basically using single inheritance. So I have to place in the base class, so that's going to be student score. Now that's fine. Now the question is, I'm going to create an instance for the child class and then run the program. So I'm going to say student or student, it doesn't matter student or students, and the instance is created, student record, right? And we will run the program. So in this case, print math score. Okay, so maybe I can give a space there. So let me reiterate the program one more time. I've got a init method present in the parent class, and we got the init method present in the child class. Now I'm creating the object for the child, but I want to use the methods present in the parent. Now let me run it, and I want to know which method is being called. So I'm going to run it, because we know that init is a constructor, and the minute that we instantiate the object, the init method would be fired. So we would like to know which init method is getting fired. So let me run it. So I'm seeing here students records and those asterisks. So that means we are only getting the init method present in the child class as the output, but we would want to get the output from the parent class. So even though I have mentioned the parent inside the child class, yet I am unable to reuse, or in other words use the code or the method that is present inside the parent class. How are we going to do that? That is where the keyword called as super comes into place. So this is a powerful keyword, we have to specify the word super followed by parenthesis and place a period sign and use the init method, call the init method. So in this case actually I'm calling the init, and when I use this, immediately the init method that belongs to the parent class would be fired. You will be able to see this exclusively. So I'm going to run it. The minute I run it, both these init methods fire. So the first one would be fired, would be the init method belonging to the child. The second one would be the init method belonging to the parent. So you can clearly see that. Let me run it. I'm running the program, so clearly you can see that. So please enter the math score. Say its score is for 25, so I'm entering 20. I should get 80. So that is the output that we have got. So this is what we have achieved using single inheritance, and we have utilized what is called as the super keyword. Now going further, what we have to do is we would want to include two classes more, and then we would want to know how exactly we could use the init methods belonging to the parent classes. So that is exactly the concept of multiple inheritance. So we would now go forward in achieving that. Okay, students, so now what we're going to do is I would want the students' extracurricular activities also to be published in the students' record. So for that, what I would do is I will declare a class and then say it as students ECA. ECA stands for extracurricular activities. So let me name it in this fashion, extracurricular. So now we will have an init method, and in this init method we would want to know what extracurricular activities the student has performed. So I will want to have the variable. So self dot say ECA is equal to input. Please enter the students ECA, extracurricular activities. So I'm receiving the input here. So I want to know the students ECA performance, and then for that I will just say input students ECA performance. So the teacher can say whether it's good, bad or fair. So now what we have to do is in the final output we want the output from the student score, output from the student extracurricular, all of these two outputs featured in the student record. So for that we would also need to give a print statement. So print students ECA. So that's going to be, it's already a string. I don't have to convert it into a string. I can just say concatenation self dot ECA. So that's the ECA. Next, I also want a print students participation level in ECA. So that was also going to be a string. So self dot ECA performance. So I've got these two things. So I need to place one more thing. So that is students math score, because we are converting into percentage. So I would say math score in percentage, in percent, just to give some air of clarity. So now what I'm going to do is I'm going to inherit student score and student extracurricular classes into the class of student record. So now when I am firing this, when I'm running this, I would want the output to feature this method, the first one from the child class, followed by the next method from the parent class, followed by the subsequent method from the next parent class. So we got multiple inheritance present here. Now the question is, with this method we will be able to fire the init present in the child as well as the init present in the first parent. The first parent, this is going to get fired, but how are we going to get this fired? Okay, let me show you that. Now after getting this fired, the parent fired, so all we need to do is to just place super within parenthesis, place the parent student score, the first parent, and after that you place a comma and then you place the self keyword followed by a period and underscore underscore init. So you need to just place that init there, and that is sufficient. I'm going to run this. So there is you can provide a space, but it doesn't matter. Even if you don't provide a space, still it will work it out. But this is just for people's understanding. So I'm running this. So as we had expected, we got the header. Now please enter the math score. So it's for 25, I already mentioned to you. So student gets 20, and then the math score in percent is 80, and then please enter ECA. So the student likes to do R programming, and then I'm going to enter student's performance is A. I give an enter. So this is the output. So students ECA is R programming, students participation level in ECA is A, and the process gets finished. So this is how we can use multiple inheritance to achieve our objective. Now there is actually another way to call the init. Now just in case, in this case I'm using the super. Now there are a lot of advantages in using the super keyword. If we do not use super keyword, we will be missing out on those advantages. Now one of the main advantage of using the super keyword is that we will be able to use dependency injection when we use super keyword. So that is a very vital advantage, and conventionally most of the programmers, they prefer to use super keyword. Now if you don't want to use the super keyword, it is fine, but still we would be able to invoke these methods. So how are we going to invoke these methods? Now alternatively, we can trigger, or in other words, we can fire the init methods associated with the subsequent classes. So what we need to do for that is to copy the first class and then follow it up with a period and then call the init method or the init function. So make sure to place the self keyword, otherwise you would have issues. Now following it up with the second class, I want to invoke the init method associated with the second class, and now I'm going to run. So when I run it, you can clearly see the output would be the same. So the student's math score upon 25, student has got 20. So math score in percent is 80, and please enter the student's ECA. So I want to give the ECA is music, say playing the guitar playing, and what's his performance, say A, and this is exactly what we had got in the previous case when the program was executed. So ECA, student's ECA is guitar playing, student's participation level is A. So this is how we use multiple inheritance with the super keyword and without the super keyword. Now the next illustration would be, what if we have three base classes? How are we going to invoke the init method? Now what I'm going to do is I'm going to be commenting these two lines of code and moving on to show the illustration. Now I need to have one more base class here. So I've got student score in math and the students extracurricular. I want to include a base class. Say for example in IQ tests, say math competitions like FIRMA. So this is going to be a class, and this is the base class, and I'm going to define the init method, and inside this I'm going to say self dot, or I would say competitions, and then I would receive the input. So let us assume that we are expecting results for the recent math Olympiad. I would want that. So input or anything for that matter, any math competition for that matter. Please enter students recent math competition. So this is very recent. Or I would say please enter the name of students recent math competition. So having obtained this, what I want to know is I want to know students performance. So this is what I have entered. In fact, if this is too big, I will just take this off. Please enter recent math competitions. I'll just use the word international. So now with this, what we are planning to do is we would want to know the students' rating. Okay, self dot rating. So what's his or her rating? So input, and we would want to print them out. So I would say print student recent involvement. I would say recent competition involvement, and then I would want to print that out. So I will say plus, it's already a string, so I don't need to convert it. So it's going to be self dot competitions. That's fine. And I would want to get the print of the student's performance. Student performance index. I'll rather be on the safe side by converting it into a string. So str of self dot rating. So this is converted into a string. Let me just have this as an integer, int. Okay, so we are all set. We are getting these informations, and we would have to use these. So we have got three base classes. Now with this code, I want to take this, commented this, I'm taking it off. Now with this code, I would be able to use the init present in the base, the first class, as well as in the second class. But now the question comes, how are we going to use the init that belongs to the third class? Now with this line of code, student score comma self, this base class would be fired. We have already seen it. But to get this base class fired, what we need to do is we need to just copy this. I'm going to copy this, and I'm going to come over here, and I'm going to say super, within parentheses I'm going to put that base class, comma self, followed by a period, and underscore underscore init. I will be calling the init here. Now with this method, what happens is that the third base class, which is featuring here, would also be called. by this line of code. So I'm exactly going to show you that. So let me run this. Upon running, we are getting the first one. Please enter the math score. Students, the score is for 25, so the student gets 20. The percentage of the student in math percentage is 80. Students ECA is, say for example, R language, and students performance is A. Enter. Students ECA is R language and students participation level in ECA is A. Now comes students, please enter recent math international competition. Say the student has taken part in FIRMA, that's a competition, math competition. The student's performance index is, say, 9 and 10 is the highest, 9 being a little bit down. So the student has got an index of 9. That means the student is a good student as well as the international competition is concerned. So I'm just entering it, and that is exactly what we are getting. We are getting to see the student's recent involvement in FIRMA and his performance index being 9. We have got all the required output records for the student by using 3 base classes. This is how we use multiple inheritance, specifically when it comes to the context of the init. Now there comes a scenario. What if I don't want to use these 2 lines of code? Because in this case I'm using super of student score comma self, and then I'm invoking the init, followed by super of student extracurricular comma self. I just want to use super. How could I still use super and get the result that we just got by executing the lines of code? So how am I going to do that? Yes, there is a way. We can in fact invoke the init present in all of these base classes just with one super init. I'm going to take this keyword, the super keyword, this line of code I'm going to copy, and I'm going to place them in every base class. So this is the first base class, I'm placing it, and then this is the second base class, I'm placing it, and this is the third base class, I'm placing it. Okay, so all I'm doing is I'm just placing the init method in all the base classes. So now I'm going to create the object for the child class, which is student record. The object is being created here. Now I'm going to run the program to show you the output. So let's see what's going to happen. Student record, please enter the math score. Student has got 20 on 25. Student's percentage is 80, right? The next one is what's student's ECA? It's R language. And what's his performance? A. Next, what math competition? So I said FIRMA. And what's his index? Say 9. And there you go. The exact output that we just got, we were able to produce the same output that we just produced in the previous case, where we used these lines of code. But now we have just removed these lines of code, commented them, and we are just merely using the super keyword. So clearly we know how super the keyword super is. Now welcome students. In this class what we are going to do is to learn how to use inheritance with regard to passing arguments for the parameters that are featured in the class. Now in the previous illustrations we have learned how to obtain the input from the user, but we never discussed how exactly we can use inheritance when it comes to passing arguments. So that is exactly what this class is going to be. So to start off, what I'm going to do is I'm going to declare a class going to be employee, and I would want to start with the init method. So I'm going to define that, and within the parameters we got self there. I want to pass the first name, the last name, the employee number, the salary. So this is going to be the standard set. Now if you were to take an organization, you will have lots of employees, but there are a lot of classification among the employees. So that is exactly what we are going to do. There are certain benefits that would be applied all through the board for all of the employees, but certain special privileges would be given to certain classes of employees. So we will try to achieve that in this particular illustration. Now, having mentioned that, this employee class which I've just defined here is going to be applied all across the board. So that would mean that this is going to be common for all the employees. So the first thing that we need is the first name. So I'm going to state and self.l.name is equal to last name, and email, I can always get the email from the first name, and I can add a period followed by the last name, and this has to be concatenated with the domain extension. So we are going to consider employees at python.com. Now, having got this, please remember that we have not given the email, but we are extracting the email from the first name and the last name. So next would be the employee number is equal to empno. So that is fine, followed by salary, self.salary is equal to salary. So this is the required variables for the organization. Now after this, what I'm going to do is I'm going to create a child class. So class, and I'm going to name it as categories of employee. So what I will do is inside the child I will place in the parent employee. So the meaning of this is the child class categories employee is going to inherit all of the methods and attributes present inside the employee class. So that is the meaning. So now I'm going to create an object. I'm going to say emp1 is equal to categories, and inside this I would want to pass in the arguments. So I will start passing the first name. Say I will say Tara, and the second name Luke, and the employee ID is 120001, and the salary say $3,000. So we got this. Now if you wanted to say place some incentives, say for example there are certain employees who would really perform well for the month, so in that case you can add a variable, a class variable called allowance, and that to be as 1.5. I will explain to you what exactly this means, allowance of 1.5. So now what I wish to do is get the details printed out. So as far as the child class is concerned, all I'm doing is I'm just creating this particular object. So now I would want to print the first name, last name, employee number, email of the employee. So I will be using the object emp1 to get the first name, and the same object emp1 to get the last name, the same object emp1 to get the email, and the same object emp1 to get the emp number, employee number, and the salary emp1 dot salary. So I have not created any methods in the child class. All I'm doing is I'm inheriting the methods of the parent class and then utilizing the object created in the child class to access all of the information. So now I'm going to run this particular code, and clearly you can see the output. First name, last name. In fact, we have the email featuring there. This is the email, and then the employee number and the salary. Now of course you can make them a little bit more attractive, but the object is to understand the concept of single level inheritance when it comes to passing the parameters. So students, what we're going to do now is to make this program a little bit different. As I mentioned to you, in an organization we can have different classification among employees. So we are going to introduce a new group. So just imagine this particular person is now demoted to the normal class. So we would have to make some changes, and we would want to bring in someone else to be featuring as a special classed employee, and the allowances have to be changed. So what I've done here is I have this allowance 2.0 for all of the employees across the board, and now I'm placing in the new allowance of 3.5 for special category employees. Now what I'm going to do is to remove this special privilege categories from this employee, and then I'm going to create a new object and call it as EMP2. Now for EMP2, the object would be created under the child class. So that would be categories employee, and I would just change the names here, employee number, and salary, let it be maybe $2,000. So I have also changed the salary. Okay, initially I took it as 3,000. I will keep that as 3,000. Then the salary for this particular person, categories employee, I'll keep it as 2,000. Now I need to have a different allowance calculation for this particular employee, Sarah. So first let me print the object. So this is going to be EMP2, EMP2, EMP2. So I'll change in these things. This method is the new method that I've introduced. So this is the special allowance calculator. What it exactly does is that it takes in the salary, and then to the salary it multiplies the percentage that we have mentioned here, and then adds up to the salary and then returns the value. What we have to do, we will have to call this method. So after the creation of the object, I'm going to use the objects to call these methods. So first I will use EMP1, call the method, and then over here I will use EMP2 to call the method. Now you will see a huge difference. Now please note the allowances given here, 2.0. So 2.0 times 3 would be 6,000 plus 3, 9,000. Now in this case it's going to be 3.5 times 2. So that's going to be 7,000 plus 2, 9,000. So both of them will land up in 9,000 if everything goes on well. So clearly you see that. Now this is because the yardstick that we use to calculate 2,000 is this. The allowance is 3.5%. Now the main important point that we have to observe here is, though we are having a child class which is inheriting the parent class, when we create the object for the child class is exclusively treated with that privilege, because the privilege here is 3.5, and that privilege is added even though this method is featured under the parent class. So we got uniqueness here. Similarly, this employee EMP1, which has been created by the employee class, has this allowance feature. So there is no mix-up at all. So this is the important feature of this particular lesson that I wish to bring to your attention. Even though this method features under the parent class, yet when we invoke it using the object created by the child, the output is totally different. Say, you can clearly see if I were to change this to 3000 and if I were to run it, I would get a different output altogether. You see, this is exactly the rate that is calculated when the allowance is 3.5. So this is how we use the single level inheritance when we are passing in the arguments for the parameters. Welcome students. In this class we would be learning how to use the super init keyword. In other words, we would be learning how to invoke the init method using the super keyword. Now, in the previous example we have already studied about the illustration of how exactly we can use single level inheritance and pass the argument, and subsequently we also looked into multiple level inheritance. Now in this illustration we are going to be looking into a similar kind of example, and we would use single level inheritance, and also we will learn how exactly we can use the super keyword. So we will start off with this illustration. I'm going to say class employee, and I'm going to give the init method. Now before I could give the init method, I'm going to give what is called as a special allowance, just like in the previous illustration, and let it be 1.0. Now this is going to be the init method. So this method will be responsible in taking the first name, the last name, EMP number, the salary. So this is going to be all across the board. So I'm going to say self dot first name is equal to first name, self dot last name is equal to last name, and self dot emp number is equal to emp number, and then finally self dot salary is equal to salary. Now as I mentioned to you, this is going to be applied to all of the employees in the organization, and as I mentioned to you, an organization is going to have different categories of employees. So not all employees will be treated alike in any organization. We all know that. So now what I'm going to do is I want to declare one more method for calculating the allowances. Of course, this is just to give a refreshment, right? So this one is going to be salary allowance calculator, and this method will be involved in calculating the salary. So it's going to be self dot salary is equal to self dot salary positive sign followed by self dot salary times the, I would have to multiply with the allowance. So in this case the special allowance, special underscore allowance is the class variable, so I can use that. So if in case you want to change it, you can always you are allowed to change it. So this is going to be self dot special allowance. So I'm going to take the integer value just to be on the safe side. So it's going to be int of the calculation. So I have got this method with me. So now I would want to write in the child class. So it's going to be class, and I can say class, we gave the class name as best employee, so I will just retain it like that. And now this is the child class, so I'm going to have the parent there. So this is going to be inheriting all the acts of the parents. But I want to place some extra attributes, some extra additional methods into this. So one of them was going to be the special allowance is going to be different for best employee. So I'm going to say special allowance 2 is equal to say 2.0. Now, having stated this, let me create the class, or I would say let me create the objects for this class. So it's going to be emp1. emp1 is equal to, I'm creating the object to start off with. So just to have a recap, let me start by creating the object for employee. So employee is created, so I'll pass in the data. I will say Sarah, the first name is Sarah, comma job, and then I will have to give the employee number, so it's going to be 120005, and then salary maybe I'll give an integer quantity of 4,000. This is the monthly salary, 4,000. Now, if I were to print this, I would get a clear result. But let me create one more object for the child class. emp2 is equal to best employee of this one. Let it be Jira and Hans, and then employee number 120006, and then salary say 5,000. So if I were to, before I could run it, let me just print these things off. So we would print it here, printing the output. So that's going to be print of. So I will have to start off by getting the first name. So I'm going to say emp1 fname and emp1 dot last name, and the next one would be emp1 dot employee number and emp1 dot salary. So I would also copy the same thing, copy this, and then I would get it printed. So this is going to be emp2, 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 emp2. So that's fine. Now if I were to run this, you would get the details of the first employee and the second employee. That's all. I wouldn't get anything much from this. So clearly you can see that the first employee, Sarah, first name, last name, employee number, and the salary. So nothing much in that. Of course, we were able to produce the data. Okay, that is a big thing. Now, what we have to do is we are allowed to perform the salary calculations, with their allowances. So what we can do is we will have to invoke this method. So for that, after this, I'm going to use this object emp1, and I'm going to trigger this method. So this method is triggered. Now after I have triggered this salary would be the exact salary for the first employee. So that's going to be 4,000 plus 4,000, so it's going to be 8,000. So, but the second employee, which is the object created for the child, that wouldn't have any difference at all because we are not calling the method for the child. So I will show you the output. You see that this is what I was telling you about, 8,000. So now comes the point. If in case, So this category is best employee. Now you want to have a different allowance for this employee too. So in that case, what we would have to do is we would have to create a new method. So that's exactly what I'm going to do. I'm going to create a new method, and I can place that method inside the child. So that's going to be allowance 2, or in other words, second type of allowances that we are using. So it's going to be allowance, salary allowance underscore calculator 2. So now I would have to invoke this method. Now you can clearly see that by following this procedure, we would be exclusively differentiating what we exactly want from who, or what we exactly want to give to who. Now if I were to run it, it was going to be a different one. So you see that 15. So this particular way is well organized. Now where exactly are we going to use the super keyword? That is critical. Now this is the illustration that we have performed and we have understood. Now imagine you want to include 2 more arguments in employee 1 and in employee 2. Now in that case, the entire program has to be changed, because the list of arguments that we have used here are the ones that are featured in the init method that has been initiated, or that is present in the employee class, in the parent class. But now there is a need that we need to include 2 more arguments in the object, emp1 and emp2. So how are we going to do that? We don't want to rewrite the code, because we would have to still obtain the first name, last name, EMP number, and the salary. We don't want to write the code again to obtain all this. But yet still, we would have to find a way by which we can utilize the parent class and also add some extra features for the child. So this is how we would be doing. So foremost, what I would want to do is, to achieve this, I go up all the way to the child class, and I would declare a init method. So this is going to be init, and in this init I would want to have the first name, the last name, the EMP number, and the salary. And now I would want to know the language that these employees are using, or in other words, their past experience on this language. So I want to take the platform, language platform that they were exposed to, and their experience. So I would say professional experience in this particular field. And probably I would also want to give free schooling for their children. So I wish to know the number of children that they have got. So I would just say number of CH or CHLDRN, something like that. So I'm including 3 parameters here. Now in an organization, if you wanted to give allowances, there can be several allowances, several different types of allowances given to different types or different categories or different classification of employees. So you can imagine the number of parameters that has to be featured here. So from this you will know why the parent class is so much critical, and why reusability of the code is so much vital and important for us to preventing redundancy. Number 2 is saving time. Number 3 is debugging. That's a big thing, because every time you introduce one line of code, and if you have missed some very vital ingredients of the code, or some vital topography is missing, then that would throw up scores of exception. So we are preventing all of that. So that is exactly why we are going to show you the importance of the super keyword. So now my objective is to not rewrite the code, but protect, or I should say use the codes that were present in the parent class in getting all of these information, the first name, last name, EMP number, salary, and just append the code for these three parameters. So that is what I'm going to do. Now that is achieved by this particular line of code. So what I'm going to do underneath, I'm going to come here and I'm going to use the super keyword. So I'm going to say super and open and close parentheses, and then place a period sign and put underscore underscore, and we need to give the init. Now inside this init I would want to use the first name, the last name, the EMP number, and the salary. So this init belongs to the parent class. Now for the rest of them, what I'm going to do, I'm going to use the class variable self dot lang platform is equal to lang underscore platform. That's fine. And then self dot pro experience is equal to pro experience. So that's fine. Now there's one more thing. It's going to be self dot number of children is equal to number of children. So these are the three additional parameters. Now the next step is, of course, we can still keep this method for calculating the allowances. Now I need to create the object. The object is created by EMP1. EMP1 and EMP2 are the two objects. But over here what I want to do is I would want to take this from the employee class and I would want to place it here, and I don't need this now because these two employees have done some new languages and they have got some development experience, so they have some skill sets that are critical to the company. So because of that they would be featuring in the best employee category. So now let me just pass in the argument. So I want to say the first person's platform is Python, and the pro experience is the person has got 3 years of pro experience, and the number of children the person has got, say, 2. So Sarah has got 2. And coming to Jira, so I would say Jira is good in C language, and the number of experience is 2 years, and she has got one child. So that is fair enough, and we can simultaneously invoke the method for both these employees. That's okay. So because of their professional experience they would be given extra benefits. Now the point comes here is, how are we going to get them printed? So I'm going to start out by saying emp1 dot, I need to use the variable lang platform and pro experience. So this is going to be emp lang underscore platform emp1 dot pro experience, and then emp1 dot number of children. I hope I got the variables correct. Number of children. Okay, that is fine. CHLDRN. Okay, now let me copy this and use it again. And this time the object is going to be EMP2. So there should be one more thing we need to do. We need to change this thing to best employee, because if we had to run it, we would get an exception. So after placing in all of these things, we see that the EMP1 is equal to employee. So the point what I wish to do now is I need to change this to best employee. So in this fashion, I'm creating the object emp1 to be featured under the child class. Now if I were to run it, let's run it and see the output. Clearly you can see the first name, the last name, the EMP number, the salary, the language that they have been working on, the experience, and the number of children that they have got. Now of course we can little bit beautify the output. So by coming over here, in case of pro experience, what we can do, we can just say plus within quotes 5 years. So the only point that we need to do is we need to change this into str of, because that's a numeric value, and number of children also you can change it to str of, and then you can concatenate it with the children. And just to show you how the output will look. So this looks fine, and in this fashion you can follow for the other object also, but our intention is to understand how exactly we can place in the 2 additional parameters so that the arguments can be sent in. That using the super keyword, I am able to add 3 extra parameters, 3 extra arguments, I should say, for each of these objects. So if I were to run it and show you the output, clearly you can see 3 years and 2 children. So this is just to make the output a little bit more presentable. So that completes our lesson, students. So students, moving on, we have reached up until this stage. Now what I wish to do is I would like to introduce a new class of project manager. Now we've got developers here, EMP1 and EMP2. Now we would want them to be directly reporting to a project manager. So for that I would want to have another child class. So we got one child class already here. So what I want to do is I would want to create another child class and call it as project manager. So this is a child class, and this will inherit all the things from the parent employee class. So this is going to be in this fashion. Now what we have to do is we would want to declare an init method for this child class project manager. So I would want to start off with the init, and in the init this would be utilizing the methods in the parent class employee. So I would have to place in the following arguments, or I should say parameters. So I'm sending in the following: first name, the last name, the EMP number, and also the salary. Now this is the init method exclusively for the child project manager. So for this I would want to add one important parameter, which would be the team. So naturally, if this is the project manager class, then it has to have a group of members who are in its team. So what I'm going to do is I'm going to say team is equal to none. Of course I can pass a list there, but you have to understand that lists are mutable data types, so we should not pass them as a parameter. So that is why I'm going to use team is equal to none. Now after this I would want to utilize some of the methods present in the parent employee class. So for that I need to use the super keyword, super followed by the period and the init method. So this init would take the first name and the last name. Of course we need to pass in the EMP number and the salary. So this is fine. Now coming back to our init present in the child class, we need to do something about this particular parameter. So for that, what I'm going to do is I need to set a condition. The condition is if team is none. So if there aren't any members assigned, then what should I do is I should say self.team should be equal to an empty list. So I'm going to give an empty list there, right? So that means I would be able to pass in the values for the list. Now if this fails, if this is not the case, so I would have to give in the else statement. So else, what I would do is self.team would be equal to team. So this is critical. Now after this, I would want to place in a few of the methods in this child class. This particular child class should have the following three attributes or following three methods. One is to add members, next is to remove members, the third one is to get the members printed. So for that, the first thing I would do is to add members. So add, let's say add team members. So for this, I would have to pass in the member. So let me pass in as EMP. So I need to check if EMP not in self.team. If it isn't so, then after this check, I would have to append. So self.team dot append. Within parameters you pass the argument, so that's going to be EMP. So this is finished. This is done for as far as the adding members. So let me just copy this off. Now I need this one more time for deleting members. So this is going to be del team members, del team members. So if EMP in self.team, then self.team I need to use remove. If this method is called, then you remove the EMP. Now I need to place in one more method. So this is going to be printing the team members. So print team members. So I don't need to pass anything here. So it's just going to be self. So for this I need to run a for loop, otherwise we wouldn't get all the members here. So I'm going to say for EMP in self.team, I would want the members to be printed. So this is going to be print. Now you can place any symbol for the data. So what I'm going to do is I'm going to place some asterisks there and a colon, and I would place a comma. So this should be the members. So what I can do is I would just write the first name. So emp.fname. So that would be the output in this case if I were to call this. So having set these methods, so now it's time for us to create the object for project manager. So let me just go and say project manager mgr is equal to, so an object is created. Now we need to pass in the values for this object, the arguments. So the arguments should be given in this fashion, just like the case that we had done for other members. So I will start out by saying project manager name is say Tom, and then first name, and next name is say Das. EMP number is integer, so I'm going to start with EMP number 5001, and the salary has to be given. So salary is what, 5,000. So that's the salary. So Along with this, we need to give an empty list. So that's critical. So this is the effective creation of the project manager. So all the three data items are there: the name, the first name, the last name, the employee number, and the salary, along with the list. So now after we have done this, what we need to do is we would have to pass in the employees, the team members. So for that, what we have to do is we cannot simply pass in the team member here. If we want to add a team member, we just simply cannot pass in the team member here, because if we were to do it, it would immediately tell us that that member is not being present or created, because our team members are starting right from here. So for that case, I would just copy this and I would create it right over here, so that I wouldn't have an issue. Because if I were to add EMP1 here, EMP1 is already created, so I wouldn't have an issue in that case. So that is why I need to place the project manager right behind these objects. So this is the creation. So I would want to get them printed. So for printing, I would have to call this method. So print underscore team underscore members. So I will use this pmgr dot print underscore team underscore members. So this is the print statement that we are using. So once I execute this, I would have this person's name printed. So let me run it and show it to you. So if I were to run it, clearly you see that Sarah name is received. Now this is just the first name. Now if you want, you can get the emails of the person printed, or in case if you want to include the project that the person is working, you can also do that. So in this case, this is printing as the first name. So what you can do is you can also just say copy this and you can say salary, right? So that would also get printed if you are interested, because let me just run it and show it to you. You see that salary, basic salary is 4,000. And the other two things we have already seen it. So these are just continuation of the program that we have already executed. So in this case, this is the vital thing. Now, if in case you want to add another person, all you need to do is just go over here and copy this, and then to add a member, it's actually add team member. So imagine you want to bring someone on board. So in that case, we will be using this add team member. So for that, to add a team member, we'll have to pass an argument. So to pass an argument, we would have to pass EMP2. So I'm going to pass EMP2, and then I'm going to print the members. Let me copy this, and now I will print the members and show you the output. So clearly you can see that this is the first employee, salary, and this is what I wish to bring it into account. So I am clearly printing, or I would say I'm clearly adding a new employee here called Jira, and the salary is also getting printed. Okay, because we are basically invoking the members here. So why those two members were printed? Because you can clearly, the reason that Sarah was printed the second time is because Jira was the person who was added. So the list already has Sarah there. So that is the reason Sarah is getting printed. So that is a beautiful point in it. So now if you want to remove this, so I can always remove it. So go back here to delete. I need to call this method. So that's exactly what I'm going to do. So I'm going to go here, and then I'm going to invoke that delete method. So pmgr dot delete. So I want to remove one member out. So EMP1 I want to remove. And after removing EMP1, I want to print, just to show you how it looks. So let me execute the program. You see that Sarah, the first one, second time the Jira was appended and it was printed. So this is why we are getting this thing. And next time we remove Sarah, and since Sarah has been removed, only Jira is present here. So that's why we are getting the output. So this is a beautiful program by which we have demonstrated how exactly we can use the super keyword with two child classes. So one class has been the best employee class and the other one is the project manager class. And we have also applied the concept of list and created 3 new methods by which we can add a team member, delete a team member, and print the team member. Thank you, students.